Thank you for joining us here today. We have some follow-up questions from our webinar. Last week we did GxP compliant calibration, learning from Form 483s and warning letters. And one of our webinar presenters was Heather Wade from Heather Wade Group. So welcome, Heather. Today we're going to do some follow-up questions that you got during the webinar. We didn't have time to answer them. So thanks for taking this time to do that again today. So I'll just start with the first question.
Yeah.
Does an internal QC lab for a pharma company need ISO 17025 certification if they do not claim conformity to this standard?
No, they don't need it because it's a voluntary standard. And I would also, unless it's required otherwise, and I'd also like to differentiate between certification and accreditation. It's a common confusion. Certification is for personnel or product, or you might be ISO 9000 registered or certified because you received a certificate of registration. Accreditation is different, and it's a more robust assessment of technical competence. So you want to be proud that if you have 17025 accreditation, that you refer to it as 7025 accreditation. And then adding on to that, with accreditation, almost all of the accreditation bodies in the world, those are the organizations that would assess as a third party labs for 17025 accreditation. And those you can easily search their websites for a company name or the parameters that a company is claiming accreditation for. So you want to make sure that you go to that accreditation body's website or contact that accreditation body for the most current and up-to-date and correct accreditation scope for a company, whether it's for testing or for calibration under 17025. That's because, unfortunately, sometimes on a company's website, they may have an outdated or sometimes even a falsified scope of accreditation or claims that they're accredited. And the accreditation bodies work very hard to track these companies that may do that, so they can highlight saying, hey, this company is not accredited. Don't believe anything that they say. So when you get your calibration certificate too, you may get something that a stamp of accreditation, the accreditation logo, that is the evidence of metrological traceability. That's the other thing to remember. And as you're looking at the calibration certificate or the test report, anything that isn't on their scope of accreditation, they must say and denote what measurements are not part of their accreditation scope. So that's also a really important thing to know. So if you're paying good money for a calibration certificate and you get that and you review it and you see, hey, there's some things on here that have asterisks that aren't in their scope of accreditation, I need that. So that's something to be aware of as well.
Okay, great. Next question, who defines the calibration intervals for instruments or devices?
The owner of the equipment is responsible for defining those. And in 17025, only the owner of the equipment can specify it. It can't be specified by the lab that's doing the calibration. There can be conversation and discussion to say, hey, this is often what people will use, but really that decision has to come from the owner of the equipment because they know how their equipment are used and they know the risks that they might be taking. So that's why it's up to the owner of the equipment to set their own calibration intervals.
Okay, so this next question has two parts. Part one, what factors and data should be used to justify a calibration interval when a recommended manufacturer's frequency is not available? And then part two is it acceptable to perform it at different intervals than recommended by the equipment manufacturer?
I'm going to start with the second question, that it is absolutely acceptable to have calibration intervals that differ from a manufacturer's recommended interval. You may need to calibrate every 3 months, where the vendor may say, hey, you know what? We recommend a year. And you're doing it every 3 months because of the risk of the amount of product that could be recalled due to a failed calibration is just too significant. It would just devastate your company, not only in the time to investigate, but also to do all the recalls and the corrective actions and preventive actions. So it's a balance of that risk versus the expense to do the calibration. Additionally, you may have data over time that show you this instrument is stable, and you know what, really could be calibrated every 3 years, and instead of a manufacturer's recommended of 9 months. But you would want to have those data, and you would still want to have some type of verification in that time just for your own protection. Now, the other question, what factors and data should be used to justify that calibration interval? Especially when that interval isn't available from a manufacturer. There is one guide. There's many guides. There's one that I was easily able to find through NIST. It's called NIST GxP-11, and that's good measurement practice for assigning and adjustment of calibration intervals for laboratory standards. So the laboratory standards would be what you would use to then calibrate other equipment. There's also a recommended practice. It's recommended practice number 1 through NCSL International, and that is on establishing and adjusting calibration intervals. There's a number of good practice guides, and that's something that can take some training in understanding how to do that. And that's something that I have gone through training and have experience in adjusting and setting and evaluating calibration intervals.
Okay, so we received a lot of questions during the webinar on repeatability, and rather than itemize all the different questions on repeatability, do you want to say a few words about it?
Sure. In relation to repeatability in regards to balances, there were a number of questions that came through, and some people reiterating their understanding and correct understandings at that of calibrating a balance following USP Chapter 41. You're calibrating using approximately 5% of the balances range and 100% of the balances range, as well as points in between. You don't need to go lower than 5%. And in that, you're also going to be checking the eccentricity, how the balance pan or grid, if you're weighing at different points around the pan as compared to a center load. And then as well as linearity by addition, linearity by substitution. And then the other part is repeatability. Repeatability is where you have measurements that you do over and over in a short period of time using the same person, the same equipment, the same reference standard, you're in the same environment. So you're getting that on and off, on and off, on and off measurement. And that's where, as one person pointed out, that measurement tool, that mass, doesn't need to be calibrated because it's just the same object going on and off. And I had in a NIST tutorial that I was in about calibrating balances and scales, they said you could use a rock if you wanted to calibrate for repeatability because it's the same thing. But you wouldn't want to just go grab a stone out of the driveway and have it all filthy and get your equipment all filthy. But that repeatability is what you're then going to calculate the standard deviation. And that standard deviation is what also goes into the measurement uncertainty. And those go together compared to your accuracy spec for your use of the balance. And that's how you determine the minimum sample weight or minimum weight. That minimum weight very easily can be lower or smaller than that 5% of the total range of your balance. I hope that helps clear that part up.
Also, probably not super impressive to an auditor when you show them your calibration rock. Okay. So
True.
moving,
You know, can you click?
what's the rock? So much more than a paperweight. So moving along, does the label need to be placed over the adjustment point?
Okay, so in the webinar, we talked about calibration labels and the information that needs to go on them. And I'm going to approach this question in a couple of ways. The calibration label, if we talk about it as that label that identifies the idea of the equipment, the calibration period, its due date, and who calibrated that piece of equipment, that should be easily viewable on the piece of equipment. There is no requirement that it needs to go over the adjustment port. And not all equipment have adjustment ports. If we take into the example of a liquid and glass thermometer, there's no way to adjust a liquid and glass thermometer. So you could put that label on, the calibration label, in a way that you can still read the thermometer in the range that you need it. But let's say something that does have an adjustment port, like a pressure gauge. Then you would want something like a tamper evidence seal that you would place either over the adjustment port or over the halves that would screw together, so that if anything were breached on that pressure gauge, it would be easily known and visible, because those tamper evidence seals are very delicate, but they're also hard to clean off. And that's what you want. You want to know if the equipment may have been breached, where there could have been either an unintentional or even an intentional adjustment.
Okay. So again, on calibration stickers, does a calibration sticker need to include the range of measurement that was calibrated?
It's not required, depending on the standard that you're following or the regulation. It is handy. It is a useful information, especially in the cases of limited calibrations. A limited calibration would be, for example, we'll use that liquid and glass thermometer again. The liquid and glass thermometer has a total measurement range from 0 to 100 Celsius, but let's say it's only calibrated from 0 to 50 Celsius. In that case, it would be useful to have on that calibration sticker that it's a limited range, that it's calibrated from 0 to 50 Celsius, and that they know it's not to be used beyond that. Other things that are often useful to have on a calibration label could be the accuracy. So using that same liquid and glass thermometer, gosh, that's handy, is the accuracy range. You may, or the accuracy limit. The resolution of that thermometer may be a half a degree Celsius or 1 degree Celsius, but maybe your accuracy is to 5 degrees Celsius. So by having that accuracy on there, the people that use it have a better understanding of what they can claim, and can also compare it if they're trying to use it for a test, that it's the appropriate thermometer for that test.
Okay. So a question about stateside labs, and I guess in this case it means labs in the United States or North America. What about stateside labs who are not ISO 17025 accredited, but claim to be covered under their parent company overseas?
In that case, whether it's in the United States or Europe or Asia or anywhere else, if a parent company is in a different country, any lab that they claim accreditation would have to have its own scope of accreditation. There's some examples of this, of labs that have the same name but are located in different states or even different countries, but they're accredited, we'll say they're all accredited under the same accreditation body. They might have the same accreditation number with a sub designation like XYZ 123.1, XYZ 123.2, XYZ 123.3, and so on. So each of those physical locations would have their own sub identifier, like that .1 or that .2, or even their own individual scope of accreditation. And that's for 17025. Each physical location has to have its own scope of accreditation.
Okay. So is this a correct analogy? What you said about the increasing levels of uncertainty reminds me of dubbing and redubbing video. With each generation, the quality decreases. Like the number of instruments in between your instrument and an SI standard results in less certainty.
The analogy is correct in that the measurement uncertainty will increase, but hopefully the quality of each measurement is going to be still the same, that it's still a high quality measurement. But as you move further and further away in those successive comparisons and that chain of calibration, that unbroken chain of calibration, that the measurement uncertainty will grow in size, will increase in size. It can never get smaller as it goes further down that chain. That's really important to know. And as a 17025 assessor, that's one of the things that we have to check is anybody claiming a measurement uncertainty on their scope that's smaller than something at the national or international or primary standards level? That's something we look for.
Okay. So for temperature data loggers, my calibration contractor cannot calibrate to my desired temperature range, but they tell me the device is capable of measuring to my temperature range. Is this acceptable?
What the calibration vendor may be saying is that, yes, your instrument can measure beyond what we can calibrate to. That's often referred to as the operating range. And that lab may only be accredited or capable of calibrating up to a certain temperature. And we'll say maybe they can only calibrate up to 200 degrees Celsius, but you need to use your instrument at 300 degrees Celsius. You cannot extrapolate and say, because it's good at 200, it's going to be good at 300. For temperature, you absolutely need to have calibration data that show you it is good at that 300 degrees. Let's say it was 275 degrees. It isn't necessary to have calibration points at each of the temperatures that you measure, but the range should encompass that temperature range. I hope that makes some sense.
Right. So look at the spec sheets, see your data sheets on a device and see what the operating is and the measured range is, or the calibrated measurement range. So we have
before we go on to the next question, in this case, they may need to find a different accreditation company, or pardon me, a different calibration company that's accredited for the ranges that they need if they aren't able to get that from that vendor.
Okay. So going over to dimension and weight calibration, can 0 point be used as a calibration point?
So I'm going to assume that when they said weight, that they mean balance. That when you are calibrating a balance, you do want to check to see, with no load on the balance, is it reading 0? Same with dimensional equipment, such as a micrometer or a caliper, something that you can move to check over that range, that you would want a 0 point. That when you completely close it down, does it go back to 0? Same with the balance. When you take the weight off, does it go back to 0? There's other pieces of equipment, dimensional equipment, like a gauge block would be considered like a weight for a calibration weight. It is what it is, and it's being compared to find out what that is. And in those cases, there isn't a 0 point, because it's always going to be, 2 centimeters or whatever that size is of that gauge.
Okay. So if calibration is a comparison against a reference, then what is the term when one has to tweak an instrument to bring it within an acceptable range?
The term would be adjustment, but not everything can be adjusted. So the other thing we want to take into account is if If we can't adjust a piece of equipment, and we'll go back to that liquid and glass thermometer, you cannot adjust a liquid and glass thermometer and still have a usable liquid and glass thermometer afterwards. But you could apply a correction factor. So if you are applying a correction factor of, let's say, 3 degrees Celsius, it would have to be clear of what that correction factor means. That are you adding 3 degrees to the display to get your temperature, or are you subtracting 3 degrees? So however you write the correction factor, and preferably writing the correction factor on the label, if it's something that's necessary for the final measurement, that everybody understands what that correction factor is and how to apply it.
Okay. Moving back to balances, if a balance that is calibrated gets moved from a lab bench to inside a biosafety cabinet for weighing a biohazardous material, does a full calibration need to be made, or is a verification enough?
It depends on the balance. There's many balances that are robust and stable enough to be able to be moved about on a countertop, or even moved from one location from a countertop into a biosafety cabinet. And in that case, that would need to be something that's proven and documented, and then also determined what sort of risk mitigation you need to practice, such as maybe a single point verification at full scale of the balance before you move it, and then after you move it and set it up in the biosafety cabinet, making sure it's level and that it's accurate when you put that weight on. Other balances, such as an analytical balance, they're so sensitive that sometimes just a minor bump to the balance can throw that balance out of tolerance. So those are really sensitive instruments, for a good reason, that you do not want to move them until they have been calibrated or verified to mitigate the risk that you have, and following your procedures that you have determined to say, this is how much we need to do before we move a balance. And then once it's set up in its new location, then to follow your procedure again to calibrate it and adjust it to the accuracy that you need.
So are original equipment manufacturers required to notify their customers if their equipment has a calibration out of tolerance on a standard used for customer equipment calibration?
The original equipment manufacturer or any company would have to follow the contractual obligations as far as communicating in those instances. So that would be something that would be worthwhile setting up under contract review. If a company is accredited to 17025, then yes, they would be required to notify you if their calibration standard were found out of tolerance and they had used it to calibrate your equipment in the range or parameter that were out of tolerance. If they're not accredited, it would still be good business for them to notify you, so you could do your impact analysis of the impact on your equipment.
Okay, I think we have, just one last question. What if you use internal staff versus an outside certified calibration service for performing calibrations? What should you have in place?
Using inside staff can be a great money saver on the cost of calibration, but understand the cost of setting that up internally. There might be that upfront cost in the beginning, and then your operating cost may be lower overall. To set up that internal calibration program, you would need people who are competent to do the calibration. You would need the equipment to be able to do the calibration. You'd need an environment to do the calibration, and you'd need procedures that are validated to be able to do those calibrations. You would need measurement uncertainty. You need a procedure to know how to calculate that measurement uncertainty, as well as the actual uncertainty budgets that are calculated. You need to look at the intervals. How frequently does it need to be calibrated? Control charting is a great way to track that. See what else. You need that supporting quality system of internal audits. So 17025 is a great standard to follow, even if you're not going to be accredited to it. You can use it to be compliant to it. But think of the basics. You need the people, you need the place, you need the things, and those things are the equipment, the procedures, and something to monitor those environmental conditions too. I think I got everything.
So resources.
Resources.
You're gonna need a few resources. Heather, thank you so much for doing our webinar with us and taking time to answer the questions that we didn't get time to answer, even though the webinar had a really good Q&A. And you can go and watch the webinar. It's on our site. Just put in your information on the form and you can watch the webinar we did with Heather Wade and Paul Daniel last week. Heather, thanks a lot for taking the time, and we really appreciate your expertise and help. And also you can go to Heather Wade Group, LLC. Just Google that and you can learn more about Heather and her company. So thanks again, Heather. Have a great day.
Thank you. I really appreciate the opportunity. And we will still be reaching out to people that sent in questions that we maybe haven't answered yet, or even the ones that we have in case you don't see this Q&A. So again, thank you. Come see me at www.heatherwadegroup.com, and we look forward to helping you.
Thanks again. Bye-bye.
Bye-bye.